All right, welcome. We're looking at problem number 2 on this problem set, where it reads a piece of property has a perimeter of 5.3 miles. So I underline perimeter because that is important for this problem. Part A, if you don't know anything about the shape of the property, then what is the largest area that the property could have? So area and perimeter, we know those two words. Perimeter, written up here, is the total distance around the outside of a closed shape. So for this part A, we don't know what the shape is. That's kind of a mystery. So we're trying to figure out what shape would maximize that area when given the perimeter. Awesome. So at first we started looking at a square. What if this property was a square? Well, we know that a square, all the side lengths are equal. So working backwards from the perimeter formula, we had our perimeter right here is 5.3, and we divided it by 4 since we know that there are 4 sides on a square and all of them are going to be equal. So that's how we found the length of one of the sides for this square. So now we have that. Now we can find the area since we have the length of the sides of the square, assuming that this property is a square. So we did that, 1.325 times 1.325, and we got 1.75, oh, can y'all see that? Let me zoom out a little bit. 1.756 miles squared over here. Okay, not bad. That is just assuming that our property is a square. Now, another shape that I thought that would really maximize area is a circle. So I knew it would come down to either a circle or a square. So let's figure out what this area would be given that the perimeter is 5.3 miles if the property is a circle. Okay, so what we need to know for that one is the formula to find the perimeter of a circle and the formula to find the area of a circle, which are written up here. We can see that perimeter of a circle equals 2 pi r. Awesome. So since we're already given the perimeter, we can plug that right in where P is, which we did down here. 5.3 equals 2 pi r. Awesome. Now, if so our goal is to find the area. So right here, we're solving for r. Awesome. So to isolate r, we're going to divide 2 pi by both sides. And that gave us our answer down here of radius equals 0.843 miles. Okay, we're not done because 0.843 is not bigger than 1.756. So still the square is winning. But that is not our area. We don't want to stop yet. Now that we have the radius, we can find the area. And let's do so by plugging it into the area of a circle formula. A equals pi r squared. Perfect. So A equals pi, we plugged in 0.843, which we just found, and we got that the area of a circle, let me zoom out so y'all can see that number, or the area of the perimeter, if it is a circle, is 2.23 miles squared down here. Awesome, so now we know, we can see that 2.23 is a little bigger than 1.756 miles. So going back to our problem up here, what is the largest area that the property could have? Well, we know that the circle is going to maximize our area. So the largest area we could have is 2.23 miles squared. Perfect. Part A is done. Let's read part B now. If you know that the property is in the shape of a rectangle, then what is the largest area that the property could have? Awesome. Okay, so now we have a little more information to work with on what we're doing here. We're looking at a rectangle. So let's scroll down to where my part B is. So what is the largest area that the property could have? Boom. So we started to think about some rectangles. You know, we know the perimeter is a total of 5.3, right? So what if, okay, let's make it simple and start by a simple example. What if this side length is 2? That would make that side length 2. Okay, that adds up to 4, so we need 1.3 on the other 2. That would give us 0.65 is my power. Oh gosh. Look like my power is about to go out there. All right, we're good. 0.65 on the other sides. Okay, 2 times 0.65. Ooh, we really don't like how that looks when we're trying to get the largest number possible here, right? We're trying to find the largest area, knowing that our shape is a rectangle. So I don't really like how we're multiplying by a number less than 1, because, right, that's just gonna make our number smaller. So I wanted to keep both the length and the width of my rectangle up here greater than 1. So I figured the best way to do that was just to make it into a square, right? Because we know that a square is a rectangle. So kind of what we did back on part 1, we knew the side length of our square because we already have the perimeter and we know that all the sides are equal. So to find this area, we just multiplied the 2 again to find 1.756 miles squared as the largest area, given that the property is a rectangle. Perfect. So part B was pretty simple because we already figured that out in part A. Let's move on to part C. If you know that the property is in the shape of a rectangle again, then what is the range of possible areas that the property could have? Awesome. So we kind of touched on that here in part B. So right here, this kind of helped us find our range when we had our square, because we just found the largest area that a rectangle could have, right? So we know 1.756 is the largest, so that's kind of the top of our range. So to complete this question, I was thinking, okay, I have the largest. What could be the smallest part of my range? You know, what is the smallest area I could get, given that the perimeter of the rectangle would still be 5.3, not 5.2, I've been saying 5.2, 5.3. So I tried to draw a super skinny rectangle for us, and obviously our side lengths have to add up to 5.3 because that's the perimeter. So I figured, well, what if we made this side length pretty much as close to 0 as possible? Obviously I only went to 0.01. That would make the other side length 2.64, right? And we know they're congruent, so that would make that 2.64 and that 0.01, and that would eventually add up to our perimeter 5.3. Perfect. And then if we multiply those two to find the area, right? We're multiplying length times width to find the area of a rectangle. We would find, where did I do that? Right down here. We would find that that area is 0.0264 miles squared. Wow. That is a lot smaller than our max up here, which is 1.756, right? So that's perfect. We kind of have a good basis of our range. So at first I wrote in range is approximately 0.0264 to 1.756. But notice how I wrote this approximately, because the range of this is it's interesting because you can kind of make it whatever you'd like to be. For example, let's go back up here, right? 0.01 is obviously a really small number when you look at it, but an even smaller number is 0.01, right? And then an even smaller number than that would be 0.001. And then every time we did that, we found that this number right here, this lower range, is just getting closer to 0. So realistically, if the more decimal places you add, this number is just approaching 0. So realistically, you could say that the range is just 0 to 1.756 miles squared. So that is our range. Either one of those would work, but I really like the 0 one because, you know, if you add more zeros up here, you're just approaching that 0, which is really interesting to look at. So all right, we got our range. Let's move on to our final part, part D. Is it possible that the area of the property is 1 square mile? All right. So we kind of helped solve that in our part C, right? Because we had our range and we looked at how these numbers can be adjusted, right? As long as it eventually adds up to 5.3 with the perimeter, right? We can come up with all these different types of areas, and we can almost cover every single number, or we can cover every single number from 0 to 1.756. So I said yes. 1 does fit in that range, and we can come up with an area of 1 that fits in that perimeter of 5.3. And I wanted to go a step further by proving that, so I used kind of just a simple method here. We know, so that we know when looking at a rectangle like this, let's look over here. We know that when you're adding these side lengths, or when you're adding the length and the width, it's gonna have to equal half of the perimeter. So I kind of simplified that down to, right, and that makes sense because the formula for perimeter is 2 times the length plus 2 times the width equals the perimeter. So we can simplify that down to the length plus width equals half of the perimeter, or 2.65. And then if we isolate one of the sides, we can see that length equals 2.65 minus the width. Awesome. And now we can start just plugging in numbers to make it a lot easier to find us an example of an area of 1. So I started with something simple. 1 equals 2.65 minus 1.65, right? That is true. But 1.161, right? 1 times 1.65 does not equal 1. So I went a little lower, and my next step was 0.65 and then 2. And then when I multiplied those, we got a little closer. I lowered the number down even more to 0.5 times 2.15, and we got really close, 1.075, which almost rounds to just 1. And then after lowering a little bit more, we got 0.48 times 2.13 equals 1.02, which you could round to an area of 1. So that kind of just shows you how, you know, these decimals, you know, the more decimal places you add or the lower you go, we can really come up with any area that we want in that range. And yeah, that was really cool. So yes, we can come up with an area of 1. Awesome. Sorry if that was really long. How to flip this camera. All right, that's all.